Guys, it's Miss Gephardt, and we are going to go through Age of Rocks and Fossil Notes. So make sure you have a piece of paper. Remember, you can draw pictures, you can add color, you can do whatever as we go through all of the notes. So we're going to start off with some of the vocabulary words that are going to be covered, and this is going to be a two-part video, so just be aware that I'm going to break it up into two different pieces. We're going to cover index fossils, radiometric dating, relative dating, half-life, law of superposition, uniformitarianism, unconformity, faults, intrusions, and absolute dating. So the whole idea is we're going to be looking at age, so we can see that from youngest to oldest, we've got the baby, the kid, the adult, and then the old man. Okay. So to start off with, when we look at Age of Rocks and Fossils, we're going to split it off into two main branches. The first one is called relative age. So relative age is the age of something in relation to something else. So if you have an older brother, or if you have a younger brother, or an older sister, or a younger sister, that is telling me the relative age of your sibling. I don't have to know their exact age. I know they're older than you are, okay? And something that scientists use is something called the law of superposition. So with the law of superposition, the oldest rock is always on the bottom, and it gets progressively younger as we work our way up. And we're going to use this with sedimentary rock. And the idea is we don't have to have an exact age. We know that if it's on the bottom, it's older. If it's on the top, it's younger. The key to this is what's in red. So what you see in red, you probably make sure we have, the rock has to be undisturbed. That's how this works out so nicely. So if we have undisturbed rock, it hasn't been bothered, it's been able to lay nice and horizontal, it gets younger as we work all the way up to the surface. Okay. So how do we disturb rock? And what does that mean? And what is undisturbed? So undisturbed rock is going to be what you see up at the top. Nice horizontal layers, no big deal, nothing's going on. And as we work down this picture, you can see how it looks like the rock's been messed with some. All right, so there are four things that you guys have to kind of pay attention to: unconformities, faults, intrusions, bending, tilting, and folding. All right, so let's start with the unconformity. So an unconformity is a gap in the rock layer due to erosion. So we can see right at that black line where the arrow is pointing at, there's a definite difference between the rock below that black line and the rock above that black line. So we can see the rock below it at some point in time was horizontal, but has tilted. And it tilted, and then the rock was eroded away. We don't know how much time has passed, and then we get this brick layer that formed on top in a nice horizontal pattern. So the unconformity is, it tells us that we've probably missed some layering somewhere. It's been eroded away. If we were to sort of age it, the event is younger than the rocks below it, but it's older than the rocks above it. Okay. Next, we have a fault. So we have faults that form due to a transform boundary. So we've already talked about transform boundaries, but there's a break in the rock layers. So we can see that we have limestone and siltstone, and they were formed. And then the transform boundary, the rock cracked and broke, and that's what would be the next event. So if we were to age it, limestone was oldest, the siltstone is next, the fault is then next, and then the basalt would be the youngest because the basalt came down after all those events have occurred. So the fault, just like kind of like an unconformity is a little bit, the fault is going to be younger than all the layers it passes through. Okay. Bending, tilting, and folding are just things that the earth is undergoing. So you know how plates move, you understand convection currents, you understand even things like earthquakes, things that cause shifting to occur. So if it's not nice and horizontal like figure A is, we can see some waving, some bending going on, some tilting, some folding. These are also going to be disturbed. So when we have to put them in order, it makes it a little more interesting. Finally, we have intrusions, and these are made by igneous rock, and all it is the magma down in the mantle is being squeezed through. So I want you to imagine like layers of bread, and I take like toothpaste, and I stuff the toothpaste container into the bread, and I squeeze it really hard. So it's going to kind of push up, but it might go off and spider in weird directions like you see in this diagram. The bread had to be there first before the toothpaste went through. So the intrusion is going to be younger than any layer it passes through, kind of like the fault was. So this is the end of video 1. Make sure you look to watch video 2.